Okay, this is our last example. The connection shown below is subjected to a load of 60 kilonewtons directed as shown. The bolt diameter is 20 millimeters. The washer is 25 millimeter inside diameter and 50 mm outside diameter. And the plate is 16 mm thick with the hole diameter 22 mm. Also, the nut is 18 mm high and 18.5 mm inside diameter to threads. Calculate the average tensile stress in the bolt. Calculate the tensile stress in the thread portion. Compute the shearing stress in the bolt, the bearing stress between the washer and the plate, the bearing stress between the bolt and the plate, and the shear stress in the nut. So this is the given figure. So for part 1, let's do the free body diagram. So this is the free body diagram. We resolve the 60 kilonewton force into its horizontal and vertical components. The horizontal component is 60 times 3 over 5. This must be 5. And the vertical, so that's why it is 36 kilonewtons. And the vertical component is 60 times 4 over 5, so 48 kilonewtons. So it causes the body of the bolt to be in tension. So this is the tensile stress in the body of the bolt. So from the figure, tensile stress in the body of the bolt is equal to 48,000 newtons divided by the area of the bolt, which is circular pi over 4 times 20 square, or pi times divided by pi times radius square. So 48,000 divided by pi times 10 square, the radius of the bolt. So the tensile stress in the body of the bolt is 152.78 megapascals tension. So for the second, this is the free body diagram for part 2. So the diameter of the threaded portion to the roots is equal to 18.5 mm. So therefore, tensile stress in the threads part is 48,000 divided by pi times 9.25 mm quantity square. The radius is 9.25, half of 18.5. So therefore, the tensile stress in the thread part is 178.57 megapascals. Next is the shearing stress in the bolt. So this is the FBD. So we have here the shear stress, average shear strength or shear stress times the area of the shear area, which is area of the bolt, which is a circle. So it is equal to shear stress in the body of the bolt is equal to 36,000 divided by area of the bolt, which is pi times 10 square. So shear stress in the body of the bolt is 36,000 over pi times 10 square. So the shear stress in the body of the bolt is equal to 114.59 megapascals. Then, or number 4, we have the bearing stress between the washer and the plate. So we also use this diagram. So this is for body 4, between the washer and the plate. So this is the FBD4. So when the tensile load of 48 kilonewtons pulls this body of the bar, so this washer here will be in contact with the plate at the underside of the plate, and this is now the bearing stress denoted by sigma sub p. Then therefore 48,000 divided by the net area or the contact area, which is area of big circle minus area of small circle, that would be the bearing stress. So that is sigma p is 48,000 divided by pi over 4 times quantity 50 mm square minus 25 mm square. The outer diameter is 50, the inside diameter is 25. So computing for that bearing stress between the washer and the plate, it is 32.59 megapascals. Number 5, the bearing stress between the bolt and the plate. So let's just apply the contact stress here, which is the bearing stress. So this is the thickness of the plate, remember? The projected area this time is equal to diameter of the bolt times thickness of the plate 16 mm, and the bearing force is 36,000 newtons. So bearing stress between the plate and the body of the bolt is 36,000 divided by diameter 20 mm times thickness of the plate 16 mm. So it is equal to 112.5 megapascals. Then finally, the shear stress in the nut. So this is actually punching shear stress in the nut. That's the figure. So this is the punching force, 48,000 newtons. Then it is equated to punching shear stress times the area of the nut surface here, which is equal to pi diameter of the thread times thickness, which is 18 mm because the nut is 18 mm high. So punching shear stress in the nut is pressure over force P over pi dt, where force is 48,000 newtons, divided by pi diameter of the threaded part is 18.5, then the thickness is the height of the head of the nut, which is 18 mm. So therefore, the shear stress, punching shear stress is 45.88 megapascals. So that's it for this problem. And I hope that you are able to follow this solution. These are just basic calculations so that when you are confronted with other types of problems, then you can master what does tensile stress means, uh, bearing stress, and shearing stress. So that's all.